main feature of the buffer is the reduce the gap between two different speed. Okay? It can be bandwidth, it can be the speed, or it can be whatever. That is buffer. What about the cache?
That is the speed between CPU and hard disk drive.
Speed?
Cache is for storing variables, or not variables, but data that is constantly accessed.
Frequently accessed data put in the cache, so you can use the benefit of fast media. Okay, instead of accessing the data, slow media such as a hard disk drive, you can copy such a frequently. Not all data, mostly the fast media is expensive. Okay, so if you have the cheap and affordable, very fast device, you don't have to worry about cache. You can directly use such a thing, like the memory. So when I have the 1 terabyte data, so can I have 1 terabyte the memory? Which is even not possible in our addressing the format. Okay? So at that time we have limited the memory structure, fast media. So we can copy such a frequently accessed data to the cache. That is a cache. Yes.
So the difference is buffer we cannot reuse later, but cache we can reuse like after the.
Oh yes.
That's
Even buffer you can serve for the many person, but it can be temporarily store the data to reduce the speed gap, such as streaming. But cache is reusable to reduce the gap. It's a different way of reducing the gap of the speed. Okay, so that is the cache. The database use a lot for the such a cache to speed up. And memory structure actually such a thing. So buffering. So kernel IO service system provides such a buffering. Not only just one, you can use the double buffering. Double buffering means is that if you have only one buffer, this one for the read the data from the hard disk drive, but it's slow, so keep use the buffer, then serve further the certain program. What if there's another process? Until this, the buffering is done, the program cannot use this one. So we manage the two buffer, double buffer. So once this one is used, this one receive the data and take over. So that is the double buffering. So double buffering is more popular nowadays. The bigger the better. Not always. You need to optimize the buffer size. So for example, if you are watching the video stream under slow network bandwidth, what is the name of the program in Microsoft to watch the video?
Media player.
Yeah. What's the name of the player? Windows Media Player. Windows Media Player, you can set actually the buffer size. So if you set the 1 gigabyte buffer size, you cannot watch until the 1 gigabyte the size is filled. You need to find the optimal size of the buffer by considering the performance of your data. Caching is keep the copy. But surprisingly, the algorithm, so we do not just copy the data, but we manage such a copy cache information. Like the most popular one is LRU algorithm, least recently used, so we can manage such a list of the block, the copy cache information by list, but they are organized by the list. The recently used one is the first one, and next one, something like that. So we will say such an algorithm in memory management, but the disk, the I/O management is also important. Then surprisingly, the data ratio that read the data from the cache is very high. It's more than 90%. Okay. So which means, in other words, actually, even though you are using 1 terabyte laptop, I believe 95% of the data you will not access for entire your life. It's just keep recording. It's the same thing in the real life system, in the real project. If you go to the Walmart system, they have huge amount of the data. 99% of the data never accessed. Okay? Mostly they are the transaction data. Nowadays, we try to utilize such a historical data, transaction data for data analysis purpose with the help of big data system. Okay? But most of them are never accessed. It's the same thing in personal computer. Even though I have the 1 terabyte size hard disk drive, and 90%, more than 90%, I do not know where the data is. But I usually, most of people do not delete such a data, just migrate and copy to the new server. That's the idea. Then, if we can keep the 10%, the 5% of the data which is a frequent access, we load such a data into the memory. It's the same idea of the operating system when they boot. Okay, the operating system, they actually load some of the frequently accessed the program into the memory. Okay? Then it will be faster. Okay? That is it's a database, use the same technique, operating system use the same technique. Many of the systems actually use such an idea. Even some of the databases nowadays, they use memory-based database. So they replace the hard disk drive, which are mostly frequently accessed by the memory. And we use the memory part for the data. The problem is, because due to the characteristic of the memory, it's volatile. Without power, the data is gone. We can use sometimes solid state disk drive, like your memory stick. Problem is I/O is slow. So, but the spooling, the kernel I/O subsystem provide the spooling. Where can you see the spool? Database? Database?
Around the files.
Spool? I don't think so. Where can you find the spool? I think that every day you are using the spool. No? Print. Printer. Where? When you send the print button, where your job is going to? Printer? I don't think so. Spool. First, it goes to the spool. Why? Such as printer. There are devices that can process only one job at a time. The display, it can display several things. Okay, input, in case of synchronous, it's one by one. Okay, but asynchronous, you can type, keyboard. However, print can actually print out at one printer job at a time. But there might be multiple requests. So one way is you can keep such a multiple requested printing job in the printer device. Okay, to do that you need hard disk drive or memory. It's expensive. Instead, you can use the hard disk drive as to keep such a, it's kind of in between the area data structure to keep the output of the request. Output of the CPU will keep such a job mostly used in the printing device. Then if the current printing job is done, and next one. So that's the reason you can see that when you send in the Windows, if you send the printer job, the spool, the windows will be pop. Actually not pop up. If you click, you can see the program tray. You can see the printer, the icon. That is a spool. Okay, it's in the hard disk drive. Okay, so I'm going to start today's lecture here. So from the I/O protection, we will cover the rest of the part in the Thursday. we have how many more weeks? The 2 more weeks until Thanksgiving. 2 or 3? I think 2.5.
Yeah, 12.
Yeah. So because we have class on Tuesday,
And Wednesday is Thanksgiving.
Wednesday we do not have
Yeah.
operating system.